Welcome back. This is Cambridge Assessment International Education, AS and A levels. Subject is Mathematics, Paper 4 Mechanics, Paper Variant 41, Session October-November 2023. Time allowed is 1 hour 15 minutes. Question number 1. A particle of mass 1.6 kg is projected with a speed of 20 meters per second up a line of greatest slope of smooth plane inclined at alpha to horizontal where tan alpha is 3 by 4. Use an energy method to find the distance. Use energy method. The particle moves up the plane before coming to instantaneous rest. So this is the scenario. Particle travels up the slope which is at an angle alpha with 20 meters per second, and we are given that tan alpha is, if I consider this as alpha, tan alpha is 3 by 4, and when you apply Pythagoras theorem we get 5 on this side. So when we use energy method, we know that we have a particle with 20 meters per second at the bottom. So kinetic energy at the bottom is half mv square. Mass is 1.6 kg. Velocity is 20. So kinetic energy at the bottom is 320 joules. So this kinetic energy, because it is smooth, so there is no wastage, kinetic energy at bottom will equal to potential energy at the top. So we go for potential energy. So potential energy is mgh. So 320 stays the same, mass is 1.6, gravity is 10, height is unknown. So 320 divided by 16, and the height comes out to be 20 meters. In exam, please use all this space. I'm writing it here so I don't have to move up and down again and again. So now we know that this vertical height is 20, and question demands find the distance the particle moves. So distance traveled is this, let me say this is x. So I can use sine alpha is equals to perpendicular over hypotenuse, and x is equals to 20 divided by sine of alpha, where sine alpha is 3 by 5, and you get 100 by 3, approximately equal to 33.3 meters. Let's move on to the next question. Question number 2. A particle of mass 2.4 kg is held in equilibrium by two light inextensible strings, one of which is attached to point A and the other attached to point B. The strings make an angle of 35 degrees and 40 degrees with the horizontal, as shown in the diagram. Find the tension in each of the strings. So in order to do that, we first go for resolving the forces. Let me resolve this and this, label them as T1 and T2. So this is T1 cos 40. This vertical component is T1 sine of 40. On the other side, this horizontal component is T2 cos of 35, and the vertical component is T2 sine of 35. And the weight would be mg, that is 24 newtons. So for the first equation, let us consider that left hand side forces, which is T2 cos of 35, equals the forces on right hand side T1 cos of 40, because it is in equilibrium, and label it as equation 1. I'm making T2 the subject to use it later, which is T1 cos of 40 divided by cos of 35. Simplifying, use your calculator, that gets 0.9352 T1, and I'm labeling it as equation 2. On the other side, now solve for the verticals. This force is upwards, which is T2 sine of 35. Again, you people please write here. I'm writing it here, so I have to move up and down a little less. So T2 sine 35, and on this side, this is again upwards, T1 sine 40. This should equal 24. Label it as equation 3. Now we substitute equation 2 in equation 3. So we bring this here and substitute. And I'm rewriting the equation T2 sine 35 plus T1 sine 40 is equals to 24. Value of T2 is 0.9352 of T1 times sine 35 plus T1 sine 40 is equals to 24. The only unknown in this equation is T1. Use your calculators and we get a coefficient of 1.1792. T1 equals 24. So T1 is equals to 24 by 1.1792. T1 is equals to 20.35, approximately equal to 20.4 newtons. Having done with that, T2, substitute this value in equation for T2 and you will get the second force. T2 is 0.9352 of T1. So 0.9352 and T1 is 20.4, and you get an answer of 19.078, which is approximately equal to 19.1 newtons. Question number 3. The diagram shows a velocity time graph for the motion of a bus. The bus starts from rest and accelerates uniformly for 8 seconds until it reaches a speed of 12.6 meters per second. The bus maintains this speed for 40 seconds, horizontal for 40 seconds. It then decelerates uniformly in 2 stages between 48 and 62 seconds. The bus decelerates at A meters per second square. Be careful, he's using deceleration for this symbol A. Don't get it confused with acceleration. So deceleration and this part is A. And between 62 and 7, the deceleration is 2A until coming to rest. Find the distance covered by the bus in first 8 seconds. So distance covered is basically area under the graph. That is 1 by 2 into base into height. So distance covered is 50.4 meters. B part says find the value of A. So before we do that, let us extract some data. This point right here is x 48 and y 12.6. This last point here is x 70 and y 0. This point in the middle is 62 and y. What we know is we can find this gradient and this gradient, then we can interlink them, as we know that the rate in the second half is twice of that. So applying and copying these values down, 48 and this. So I'm first finding the gradient of this section, which is y2 minus y1, y minus 12.6, y minus 12.6 divided by 62 minus 48. 62 minus 48. And if I multiply this with 2, it will actually equal the gradient on the second half. So 0 minus y over 70 minus 62. Now bear with me till I simplify. This is y minus 12.6 divided by 14 times 2 is equals to negative y over 8 on the other side. 2 1 times 2 7 times. Now this is y minus 12.6, and I'm multiplying this y on the other side, makes it negative 7 by 8 y. Rearrange the equation. Y plus 7 by 8 is equals to 12.6. 15 by 8 of y is equals to 12.6. Y is equals to 12.6 into 8 by 15, which is equal to 6.72. Having said that, this is 6.72. Now we know, and let's use this section again. And because I know the deceleration is a, I'm using this section and write it as y minus 12.6 over 62 minus 48. This is the gradient. Remember, we are finding the gradient. Y is 6.72 minus 12.6 divided by 62 minus 48, and we simplify to get minus 5.88 by 14, approximately equal to negative 0.42 meters per second square. Remember, this is the acceleration. So deceleration, which the examiner mentions by A, is 0.42 meters per second square. So this is the value of A. C part. Find the average speed of the bus for the whole journey. So now the average speed is the total distance divided by total time. In order to reduce this struggle in moving up and down, I'm copying this graph here. So this graph is like this. This is 12.6 against 8 horizontal line for 40 seconds, making it 48. Then we have two sections, 1 and 2. It ends at 70. This value in between is 62. We just found 6.72, and we know all other values. So find the average speed. It is total distance over total time. In order to calculate the total distance, I'm splitting this up in 3 regions. This is trapezium, this is again trapezium, last is triangle. So for first trapezium, it is 1 by 2 into sum of parallel sides, which is 48 plus 40, times height, which is 12.6, plus the second trapezium 1 by 2 sum of parallel sides. This height is 12.6, the other height is 6.72, and distance between parallel sides is 14. For the third one, which is a triangle, is 1 by 2 into base from 62 to 7 base is 8, and height is 6.72. So 1 by 2 into 88 into 12.6 plus 1 by 2 into 19.32 into 14 plus 1 by 2 into 8 into 6.72. 554.4 plus 135.24 plus 26.88, and this equals 716.52, approximately equal to 717 meters. Question number 4. Two particles P and Q of masses 6 kg and 2 kg respectively lie at rest 12.5 meters apart on a rough horizontal plane. The coefficient of friction between each particle and the plane is 0.4. This is mu. Particle P is projected towards Q with a speed of 20 meters per second. So understand this scenario. This is the horizontal track. Particle P lies here, particle Q lies here. This is 6 kgs, this is 2 kgs. Distance between them is 12.5 meters. Coefficient of friction is 0.4, and P is projected with a speed of 20 meters per second towards Q. So show that the speed of P immediately before collision is this. So this is how we do it. Kinetic energy. Initially, P is having kinetic energy. Surface is horizontal, so no change in potential energy. So kinetic energy initial is actually equal to kinetic energy final, which will be before it hits Q, plus the work done, we say it work out against friction. So initial kinetic energy is half mv square, final kinetic energy is half mv squared, and work done is force into distance. Now we just fill them up and solve for the unknowns. So this is 1 by 2, mass is 6, velocity is 20 as given. On the other side, this is 1 by 2, mass is 6 and velocity is unknown. Now this is the frictional force. So frictional force is mu r and the distance is given, which is 12.5. 1 by 2 into 6 into 20 is 1200. 2 1 times, 2 3 times, this is 3v square. Mu is given, which is 0.4, and r is actually the weight, which is 60 mg, mass into gravity 60 into 12.5. Now you can see the only unknown is v square. So this is 1200 is equals to 3v squared plus 300. Taking this on other side, we're left with 900 equals 3v square. V square is equals to 300, and square root both sides. V turns out to be 10 square root 3 meters per second SHOWN shown. For B part, in collision, P and Q coalesce, they stick together to form particle R. Find the loss in kinetic energy. To find the loss, I need to find the speeds. So this was actual scenario. P was moving with the speed of 20 meters per second. And this was Q at rest. And P reached here at a speed of 10 square root 3. And after they hit, they combined to form a new particle R, and it is now moving with a new speed. So I'm using the concept that momentum before the collision is equals to momentum after the collision. So momentum before is mass of P into velocity of P plus mass of Q into velocity of Q is equals to mass of P plus mass of Q, as it is given that they combine together to make R, and velocity of, let's say this is R. So initial mass is 6, velocity is before collision, velocity is 10 square root 3 plus mass of Q is 2, velocity of Q is 0, mass is 6 plus 2, new velocity of the particle R. So 6 into 10 is 60, square root 3 is equals to 8, velocity of R. So velocity of R equals 60 square root 3 by 8, and VR equals 15 square root 3 over 2 meters per second. I would like to keep it in the exact form for now. Okay, now kinetic energy. Kinetic energy initially was due to particle P, which was 1 by 2 into mass into velocity 10 square root 3 whole square, and which is 900 joules. On the other hand, kinetic energy final is 1 by 2 mass of R, which is 8, and speed of R, which is 15 square root 3 by 2 whole squared, is 675 joule. So the loss in kinetic energy, this was the initial, this is final. So 900 minus 675, it loses kinetic energy of 225 joules. The coefficient of friction between R and the plane is 0.4. Find the distance traveled by particle R before coming to rest. So this is particle R. It is moving with the speed of 15 square root 3 by 2 meters per second. And R has a mass of 8 kg. Coefficient of friction is 0.4. and when it comes to rest. So let us apply F equals ma, where F is forward force minus friction mass into acceleration. Forward or driving force in this case is 0, resistance is mu r, mass is 8, acceleration. So minus, and mu is 0.4, r is 8 into 10, that is 80, is equals to 8a. When you solve for acceleration, you get negative 4 meters per second square. Now we have the acceleration and we have to find the distance when it comes to rest. So we use equation v square minus u square is equals to 2as. Final velocity 0. Initial velocity is 15 square root 3 by 2 whole squared. 2 times acceleration is minus 4, and we'll be able to solve for the distance. So this is negative 168.75 equals negative 8, and displacement, negative sign goes with negative, displacement covered is 168.75 by 8, which equals 21.09375, approximately equal to 21.1 meters. Question number 5. The diagram shows particle A of mass 1.2 kg which lies on the plane inclined at an angle 40 degrees to the horizontal, and particle B of mass 1.6 kg which lies on the plane inclined at an angle of 50 degrees to the horizontal. The particles are connected by light inextensible string which passes over a small smooth pulley fixed at top of the plates. The parts AP and BP of the string are taut and parallel to lines of greatest slope of the respective planes. The two planes are rough with the same coefficient of friction between the particles and the planes. Find value of mu for which the system is in limiting equilibrium. Okay, so now let us resolve them first and then we'll write the equations. Consider this weight going down, which is 12. This is going to be the normal contact force, and this is the component of weight which moves down. This is 40. This is 12 cos of 40. This is 12 sine of 40. For B, weight is 16 newtons, and we resolve these two. This angle is 50, this is 90, so this is 16 cos of 50 and this is 16 sine of 50. Apart from these, we know that we have friction and it is in a limiting equilibrium. So I am taking B as moving down as it is heavier and A as moving up. So if A is moving up, friction would be against the motion, and this is friction. This is the direction of tension. In B, this is the direction of tension and it is moving down. If it is moving down, friction would be upwards. Now we write the equations. Let's say for A, tension is above and friction and weight is downwards. So I can say T is equals to friction plus 12 sine of 40. Friction plus 12 sine 40. On the other hand, for B, we see that friction is upwards, tension is upwards, and component of weight is downwards. So I'm writing 16 sine 50, which is downwards, is equals to friction plus tension. Now we can plug in few values and solve them simultaneously to find the unknowns. So for this, tension is equals to friction is mu r plus 12 sine 40. Tension is equals to mu and r is 16 cos 50. Sorry, we are doing for A. So this is 12 cos 40. So R is 12 cos 40 plus 12 sin 40. On the other side, 16 sine of 50 is equals to friction is mu R plus tension. So 16 sine 50 is equals to mu, and R for B is 16 cos of 50. 16 cos of 50 plus T. Now we have to find mu. So we can make T the subject on both sides. So 16 sine of 50 minus mu 16 cos of 50 is equal to T. So T here and T here, we can equate these two equations. T is equal to T. So this is mu times 12 cos 40 plus 12 sine 40 equals all of this, which is 16 sine 50 minus mu 16 cos of 50. So bringing mu on one side, mu of 12 cos 40 plus mu of 16 cos of 50, giving that on other side is 16 sine 40 minus 12 sine 40. So we make mu the subject and divide these two on the other side. 16 sine of 50 minus 12 sine of 40 divided by 12 cos of 40 plus 16 cos of 50. Now use your calculators to get the value of mu, which is 0.2332, approximately equal to 0.233. Number 6. A car of mass 1300 kgs is moving on a straight road. On a horizontal section, the road of the car has a constant speed of 30 meters per second. And there is a constant force of 650 Newton resisting the motion. Calculate in kilowatt the power developed by the car. So power is equals to force into velocity. And we use the given values. 650 is the constant resisting force. It is traveling at 30 meters per second, giving a power of 19,500 watts, and in kilowatt that would be 19.5 kilowatts. Second part, given that the power is suddenly increased by 9 kilowatt, find the instantaneous acceleration. Okay. So we have the formula power equals force into velocity. When the power increased by 19, initially it was 19,500 and now by 9 kilowatt, that is 9,000. New power is equals to driving force. Velocity is 30 at that time, which is given. So 28,500 divided by 30, you get the new driving force. So driving force is 950 newtons. We have the driving force to find the acceleration. This is F equals ma, net force, that is forward driving force, minus the resistive force, equals mass 1300 times acceleration. So this is 300 by 1300 is equals to acceleration. Acceleration equals 3 by 13 or approximately equal to 0.231 meters per second square. Question 6, B part. On section of the road inclined at sine inverse 0.08, okay, we'll deal with it. On the to the horizontal, the resistance to motion of the car is this. When the speed of the car is v, the car travels downwards along this section of the road at constant speed with engine working at 11.5. So car was moving horizontally and then it started moving downwards, and ratio is given. If sine inverse is 0.08, so sine of inverse of 0.08, I can say sine theta is equals to 0.08, and sine theta would be 8 by 100. So power is equals to force into velocity. Power is given, which is 11,500. Driving force is unknown. and we have a constant velocity. So driving force would be 11,500 divided by velocity. Now consider we have a resistive force and we have this condition. Let us resolve first. Weight of the car, as it was 1300 kgs, so this is now 13,000 newtons. On the other side, when we resolve these, and I know this is theta, so theta sine component, this is 13,000 sine theta and this is 13,000 cos theta. So we write the resistive forces. Resistance is this way, driving force forward is this way, and component of weight is also downwards. So actually resistance equals total of these two. So I'm writing resistance equals forward driving force plus component of weight downwards. So resistance is given in the question, that is 1000 plus 20V. On the other side, forward driving force is this, which is 11,500 by V plus the component of weight, which is 13,000 sine theta, where sine theta is 8 by 100. So 13,000 times 8 by 100. Now we have the equation. The demand of the question was to find V. You just have to simplify this equation and get your answer. So we simplifying, we get 1000 plus 20 V is equals to 11500 by V plus, what am I doing? I just copied it. We simplify these and we get 1040. Now rearranging, this is 20V minus 11,500 by V is equals to 1040 minus 1000 is 40. So multiplying the whole equation with V, 20V square minus 11500 equals 40V. 20V squared minus 40V minus 11500 equals 0. Now we can apply quadratic formula. So velocity is basically equal to minus b plus minus square root b square minus 4ac over 2a. So minus, this is minus 40 plus minus square root b square minus 4ac is negative 11500 divided by 2a, and I get an answer of 25 meters per second with the positive sign and negative 23 meters per second with the negative sign, which is rejected. Therefore, the final velocity is equals to 25 meters per second. Question number 7. A particle moves in a straight line starting from point O before coming to instantaneous rest, where velocity is 0, at point X. At time t seconds after leaving O, the velocity v meters per second of the particle is given by these equations. So from 0 to 2 this, 2 to 8 is this, and 8 to 8 onwards is the last one, where k is a constant in the third equation. It is given that there is no instantaneous change in velocity at t equals 8. So that means when we put t here velocity and t here velocity, they will be same. So it says find the distance OX. So we will go for integration. When we integrate velocity, we will get the equation of displacement. So displacement is, I'm integrating the first one, which is 7.2 t square, and limits are from 0 to 2 with respect to t. So let's do this. That is 7.2 t cube by 3 from 0 to 3, which is 2.4 t cube 0 to 3. 2.4 3 cube minus 2.40 cube, and the answer is 19.2 meters. Done for the first section. Now for the second section, velocity in the second section is 30.6 minus 0.9 t. That is 30.6 minus 0.9 t. And this is for 2 to 8. So again, displacement, we are integrating from 2 to 8. This is 30.6 minus 0.9 t with respect to t. When you go for integration, this is 30.6 t minus 0.9 t square by 2, and limit is from 2 to 8. 30.6 8 minus 0.45 into 8 and minus, now we plug in 2, that is 30.6 into 2 minus 0.45 into 2 leaves an answer of 216 minus 59.4, which is equal to 156.6 meters. So we have these two displacements. Now we need this, and in order to use the third one, I know that velocity at t is equal to velocity at t, so we can first use this equation to find the velocity when time is 8. So copying the same equation, v is equals to, this was at 30.6 minus 0.9 t, and we know that at 30.6 minus 0.9 at 8 seconds the velocity is 23.4 meters per second. So we have the same velocity. I'm using this in the third equation, which is 1600 by t square plus kt. So velocity for 1600 over t square plus kt, velocity is same, so 23.4 is equals to at time 8 plus k into 8. Simplify to get 8. So this is 23.4 is equals to 25 plus 8k. So 23.4 minus 25 by 8 is k, and k is equals to negative 1 by 5. Now I'm copying this same equation, which is velocity is equals to 1600 by t square, and k is negative 1 by 5 of t. Now we know that the condition was that it comes to rest at point x. That means when it ends, velocity will be 0. So let's do that to find t. So when velocity is 0, 1600 over t square minus 1 by 5t, take the LCM, that is 5t square, 1600 into 5 is 8000, minus t into t square is t cube, this is 0, so t cube is equals to 8000, cube root both sides, t is equals to 20 seconds. So basically this is from time 8 to 20 seconds, the third equation. To find the displacement, we again go for integration. So displacement is equals to integration from 8 to 20. For 1600, I'm taking this in numerator, t raised to power minus 2 minus t over 5 with respect to t. So displacement is power plus 1 over power, you get 1600 power plus 1, that would be minus 1, bringing it down, and minus here minus t square over divided by 2, 5 2 times is 10, from 8 to 20. Plug in the values. This is minus 1600, time is 20, minus 20 square by 10. On the other side, that is minus 1600 divided by time is 8 minus 8 squared divided by 10. Simplify both of these, you get negative 120 on this side minus 206.4 on the other side. So 206.4 minus 120 is 86.4. Now we bring all the three values. First value was 156.6. So total displacement is 156.6 plus the second value is 23.4. It is 19.2. So 156.6 and 19.2. Last one is 86.4. Adding them up gives you 262.2 meters. Thank you so much. Don't forget to subscribe.